Good morning, CNG 124 online. Welcome to Monday, a chilly, icy day. Make sure you get to travel today. You're taking precautions on those roads. They definitely are slick. Um, I'm glad to see that most of our action is during the week and with some people visiting Friday, Saturday, and Sunday. Hopefully these are review days, these Friday, Saturday, and Sundays. Um, that like I mentioned before, that's probably one of the best methods of success is to review, to not only complete the material during the week, but also review it as you're going through the week. Let's see, we start into February 3rd, week 3. Going back to week 2, some people recognized a few things right off the back. In week 2, we have one quiz in Netacad that we do, and that is simply reached by going to Cisco Networking, logging in. And at the end of the chapter 3 is going to be the quiz that we have to do. Yep. So if you click there and then go here, and then, or you can just go to quizzes. My Lookout should look very similar to your Lookout, your menus. So if you go into course module and then click the quizzes, we want to do chapter 3 quiz. And as you see, it's 14 questions, 28 points. These do not count against your, these scores are not imported into D2L, but instead, if we were to go back to the syllabus, you have to complete quiz 3 and test 9 out of chapter 9. And so how do we get to that? It's not open yet, but we go to assignments for the exam, and then we go to chapter 9 and click that to do that quiz. We're not there yet. As you see, we start to look at really different layers and break down the layers and what happens at each layer from here on out. So we got introduced to the OSI model last week. You know, the TCPI model last week. We saw that one has 7, one has 4, how they match up. Got a question about the quiz, one of the quiz answers being wrong. I think it is easier to say, if I'm familiar with the OSI model, and I say, okay, I know the switches are in this one. The switches have to be here. Perhaps I want to double check that against the TCP/IP model and say, okay, are the switches located where I really think they are? Because as we see, there is a connection between the two models, but the domains are slightly integrated in the TCP/IP model, whereas OSI, they're really broken down into 7 separate layers. TCP/IP breaks them down into fewer layers. So that's a different way to look at quizzes with that. Another good reflection on this week or last week was somebody said, I just followed along with your slides and was able to answer most of the questions in the quiz. Yes. To start you guys off, I figured this is probably one of your first starting courses. So I did make the slides very, very based off of the reading, very, very similar, and should be used as a template. If you're going to take notes, I would say print off these slides here, 3 to a sheet. I think there's even a specific name for it. I think it's just called slide preview or something. Download these, print these off in slide preview, so you have 3 slides per sheet and some lines off to the side, so you can actually look at so you can look at and take notes along with what you're reading in the chapter. This week, looks like we get into IPv4 addressing, which is basically manipulating some binary too. Let's see if I can't get into the notes. Or I was just in the notes. And this one takes the most to recognize when I start to remember. Your IPv4 is broken down into public and private, Basically, the public addresses are going to be specific ranges within your private addresses, basically. And those public ones are meant to be on the outside, the WAN connection of your devices, wide area network, where the private IPs are going to be on your LAN connection, local area network. When we look to break these down, they're going to be class A, B, C, D, E. D and E, I've seen them. I haven't seen them in action. I've seen them theoretically in action, but I have not seen them in action. Basically, they just be on a set of computers that are meant to talk to just a group of computers on a internal LAN. And usually I see really more often than not computers just broken into a different the NICs in a computer, network interface cards in a computer, are broken down into a separate network, not just put in a Class D a network of their own. Well, I guess a Class D would be another network, but I don't want to confuse you guys at this point. But I usually see them just on a different network, not in the range of a Class D, but just on a different network. Classful addresses A, B, and C. So we have Class A's. Basically 0 to 126, Class B 128 to 191, Class C 192 to 223, Class D 224 to 240, and then you have your Class E, I should say 239, 240 would be Class E, and then all the way to the end. But rarely, once again, hardly ever seen when we go to that. Actually, let me pop in the slide to show you guys. When we look at the IP addresses, this video is going to be somewhat, probably all the way to 15 minutes, just to let you guys know now. When we look at the class 4 addresses, we see that they're broken by a decimal period. Each value in between is an octet. So we have 4 octets, 256 unique values, but values can only be 0 to 255. We do count the 0 in networking. One of the few places that 0 is actually a value that we use. Remember, it's 2 to the 8th. From here on out, you're going to start seeing a lot of the same numbers. The subnet mask relates directly to the IP address. So if we had a Class C address, this would be the Class C default subnet mask. And we figure that out with a prefix of /24. Here we have defining the first address of the network is always a 0 for right now. Since we're doing classful addressing, it's going to be our first network address will always be a 0, and that would be our network 0, our subnet 0, since that's our starting point. Reserved addresses, broadcast address we cannot use, along with the network address we cannot use, because out of all of our 256 addresses, we can really theoretically only use 254 because the first and the last are taken. As we start to subnet, of course, the address range is going to get smaller, but we still cannot use the first and we still cannot use the last. Classful addressing, Class A. Here we have, once again, 1 to 126. The first octet is the only network address. So in a Class A, that first 8 bits are belonging to the network. The remaining 24 bits belong to the hosts. So we're able to manipulate those a little bit later on. But as we're learning, we have like 16 million addresses in a Class A network. Class B, first 2 octets are used. First 2 most left bits are used also. So if we were to break down, if we look at the difference here, the first octet can only be 1 to 126. So basically, as we started counting in binary, the furthest we can go in marking all those bits as a 1 is up to 126. We can't flip on the leftmost bit. It has to remain a 0 because as soon as we flip on that leftmost bit, we jump into a class B, which is a 128 to 191. So the two leftmost bits are always 1 and 0. So our two left bits, 1 and 0. The subnet mask then, since we have two octets that are being used, the subnet mask is then 255.255.0.0, and that would be our class C, or class B. Class C, the three leftmost bits in that first byte, 110, once again 192 to 223. The subnet mask then is 255.255.0 with the prefix /24. If we look back, the prefixes are really just counting the number of bits that are being used. So if you look at class A, we use that first octet. All those bits are used and belong to the network. Class B, 16 bits are used, belong to the network. Class C, 24 bits are being used that belong to the network, with 8 belonging to the host. D and E, once again, D reserved for multicasting, E experimental use. Haven't really seen those deployed in a really long time. I don't think I've really seen them used at all, but I'm sure they're out there, but just be aware of that. Here we have ANDing to find our network address. We take the default subnet mask with an IP address given to us, and basically we are multiplying. 1 times 1 will give us 1, 1 times 0 will give us 0, and we come up with the solution of the network address at that point. Sorry, I can't just click that one. There we go. And that would be our network address of the IP given. And remember, private IP addresses, they look very similar, but they're a specific range within that whole class of Class A's. Class A does not start at 10 and does not end at 10. Class A starts at 1, ends at 126. Class B starts at 128, ends at 191. So here we have a range of private addresses. Class C, same with that. Starts at 192, ends at 223, but the private addresses are within there. Special loop address 127. They thought it was a good idea that we have a loopback address 127.0 to 127. I'm sorry, 1 to 127.255.255.254. They thought it was just a good idea back when they made IPv4 just to give a whole bunch of IP addresses just one purpose. Kind of wasteful at that point. They really didn't think the internet would be that of a good idea until it actually was. Special use address, link local. If you ever plug in your computer and don't get an internet connection, your computer might get a 169.254 something/16. That's an APIPA address. Basically, your computer could not find a DHCP server and could not get assigned an IP address. Therefore, it assigned its own address for that. When doing the exercises or the activities in CNAP, you're really focusing on unicast, multicast, and broadcast. Make sure to rehearse this until it sinks in. This one will be a challenge to you. Once again, one of those ways of thinking where you have to identify what kind of broadcast is it. Feel free to pause the game also when you're doing that test your knowledge to help you understand what the unicast, broadcast, multicast is. And with that, I'll leave that for this week. Once again, we're using binary in different ways, so make sure you understand that the 4 octets are basically 4 different binary pieces, 4 different bytes, and start to work on that for this week. Make sure you practice your homework in the workbook, and I'll call this done.